Hello students, today we are going to continue exercise 8.4. Question number 5 we are going to start today, and before starting the question, let us first again read the formulas which we have studied for this exercise. First one is sin square A plus cos square A is equal to 1 plus tangent square A is equal to secant square A, and 1 plus cotangent square A is equal to cosecant square A. So these are the three formulas which we had done. Now we are going to start question number 5. Part first we are going to start. See the statement: cosecant theta minus cotangent theta square is equal to 1 minus cos theta over 1 plus cos theta. So this is what we want to prove, and in these kind of question, take left side now. My cosecant theta, I am just directly writing cosecant theta can be written as 1 by sin theta. Cotangent theta can be written as cos theta upon sin theta, right? And square is already there. What next can be done? Take sin theta LCM, and in numerator we get 1 minus cos theta only, whole square as it is. Then separate it out, 1 minus cos theta whole square separate. In numerator I am writing, and in denominator sin theta square means sin square theta. Then since it is a whole square, I can write it twice, 1 minus cos theta multiply 1 minus cos theta again, and in denominator sin square theta is there. Look at this formula, value of sin square A will be 1 and cos square A will go to right side, it will become 1 minus cos square A. So I can write it here 1 minus cos square theta. Okay, let's move ahead. 1 minus cos theta into 1 minus cos theta, numerator as it is. In denominator, have a look. This 1 I can write it as 1 square, right? So what will it become? A square minus B square. Its formula will be A plus B, A minus B, right? And see, these two terms are same, these are cancelled, and finally we get 1 minus cos theta over 1 plus cos theta, and that is what I wanted to prove. This is my right hand side. I hope you are clear with this question. It's very easy, but you need to remember all the formulas. Let's move to next part. See the question now. Cos A upon 1 plus sin A plus 1 plus sin A upon cos A is equal to 2 secant A. We are going to take left side again, right? In left side, see, already it is in sin and cos. So what I can do, I can take LCM. LCM means product of both denominators. That means 1 plus sin A multiplied with this cos A, and further what we can do, this cos A will be multiplied with cos A, cos square A. 1 plus sin A with 1 plus sin A, we get 1 plus sin A whole square. Let us solve it. We get cos square A as it is. Then this is A plus B whole square. It becomes A square plus B square plus 2AB will become 2 sin A, because when 1 is multiplied, it doesn't change the value. So 2 sin A, and denominator remain as it is, 1 plus sin A into cos A. Now see, sin square A plus cos square A. We have done the formula, sin square A plus cos square A is 1. So I am writing 1 in these places. Then plus 1 again, 2 sin A. Denominator is 1 plus sin A into cos A. Now 1 plus 1 is 2. We get 2 plus 2 sin A over 1 plus sin A into cos A. Now 2 common from numerator. If I take 2 common, it becomes 1 plus sin A. Denominator is already 1 plus sin A into cos A. So now this 1 plus sin A and 1 plus sin A are cancelled. We get 2 upon cos A, right? And 1 by cos A is equal to secant A. So we get 2 secant A, and this is what I wanted to prove, which is my right side. So it's very easy part. So first 2 parts we are done. Let's move to third part. Look at part third now. Part third is tangent theta upon 1 minus cotangent theta plus cotangent theta over 1 minus tangent theta. Look at the statement very carefully, and right side is 1 plus secant theta cos secant theta, right? So this is the question. How can we do it? We need to take left side, right? I checked that tangent and cotangent, 2 kind of values are there, whereas in right side secant and cosecant are there. So my first priority was, since cotangent is related with tangent, so I tried changing everything into tangent only. Then I will put tangent into sine and cos. Okay, so let's see, tangent theta upon cotangent can be written as 1 by tangent, right? So these are reciprocal of each other, that's why I can write this. Cotangent can also be written as 1 by tangent theta, and in denominator will be having only 1 minus tangent theta. Next step, this tangent theta as it is. In denominator we are going to take LCM tangent theta, and tangent theta multiplied with 1, tangent theta minus 1 plus 1 upon this tangent theta will be multiplied with denominator. So this is what finally we get. Now this tangent theta in denominator, it will move to top, multiplied with tangent, we will get tangent square theta upon tangent theta minus 1, 1 by tangent theta into 1 minus tangent theta. Now if we check carefully, this is 1 minus tangent theta, this is tangent theta minus 1. So in my next step, what I can do, because I want to take LCM, if this is tangent theta minus 1, I want here also tangent theta minus 1. For that, what I need to do, I need to take minus common out of it. This positive sign I am going to change to negative, and in denominator 1 minus tangent theta, it can be written as tangent theta minus 1, right? Just minus common we have taken. If you send this minus back to this bracket, you will get the above value. Let's move ahead. Now very easy to take the LCM. What is the LCM now? Tangent theta into tangent theta minus 1, because this is the biggest term. Tangent theta minus 1 is coming here, it's also coming here, so this is the biggest one, so I'm going to take this as LCM. Now this is having tangent theta minus 1, whereas my denominator now is having tangent theta as well. So this tangent theta will be multiplied with tangent square theta, and we will get tangent cube theta. This term and this term both are same, so I'll get 1 only, and 1 can be written as 1 cube. Now formula for a cube minus b cube. Formula for a cube minus b cube I am writing here. Usually students get confused. A cube minus b cube formula is a minus b into a square plus ab plus b square. So this is the formula which everybody needs to learn. to do this question. So a cube minus b cube I am going to use. See, a minus b into a square, right? Look at this, a square means tangent theta square, plus ab, that means product of tangent theta and 1, I will get tangent theta only, plus b square means 1 square, and 1 square is 1 only, and denominator is tangent theta into tangent theta minus 1. So these two are cancelled. We are left with tangent square theta upon tangent theta. I am just splitting the terms, or plus this tangent theta upon tangent theta, I can split it. Then 1 upon tangent theta. I can write, if I write denominator with all the terms, then it is perfectly fine. Now this tangent theta, and above we are having tangent square theta, so 1 is cancelled, we get only tangent theta. These tangent and tangent, if they are cancelled, we get 1, and 1 by tangent theta is cotangent theta. So this is what where finally we reach tangent theta plus 1 plus cotangent theta. Let's see how ahead we need to move. Now my next step, as I told you earlier, is to put tangent theta as sin theta upon cos theta, 1 as it is. Cot theta can be written as cos theta upon sin theta. Now what is LCM? Sin theta cos theta, their product will be LCM. So sin theta cos theta product, we have taken LCM. Already cos theta is there in denominator, only sin theta is left. So this sin will be multiplied with numerator sin, we get sin square theta plus, it is 1, right? So 1 will be multiplied with sin and cos both, we get sin theta cos theta, and then this is only cos, cos will be multiplied with this cos, we get cos square theta. Now sin square theta plus cos square theta is 1, so I am writing 1 in that place, 1 plus sin theta cos theta upon sin theta cos theta. We are going to use same step which we had used here. I am splitting the terms with denominator, writing denominator with each term, sin theta cos theta plus sin theta cos theta upon sin theta cos theta. See what will I get, this cos and cos cancel, sin and sin cancel, we get 1. 1 by sin is cosecant theta, 1 by cos is secant theta, and this is already 1. Now just reframing the sentence, we can write 1 plus secant theta into cosecant theta. This is what we wanted to prove. So we are done with third part also. It was a bit lengthy, but it is not difficult. If you have learned the formulas, this can be done very easily. So in our today's lecture, we have covered 3 parts. Tomorrow in our next lecture, we will continue doing the further parts. Thank you so much.